There are three ways to solve systems of linear equations. One is by graphing, the other is by elimination, which I covered in another video, and now by substitution, which I'll cover in this video. So in elimination, we tried to make our x's the same or our y's the same so that we could add or subtract them to get rid of either our x or our y. In substitution, we're going to use our y equals something or our x equals something and substitute it into the other equation. So it all depends on how your questions are asked. If you have a question that is in the form of y equals your expression or x equals your expression, usually you'd want to solve your systems of linear equations by substitution. If you have it in the form of whatever x plus whatever y equals something else, then you usually want to solve it by elimination. So in this case, let's solve the equations by substitution. Now in my other video on solving by elimination, I suggested to you to make sure that your equals signs all align in the same column. I'm going to remind you to do the same here because we want to keep everything as neat as we can. And I'm going to label it equation 1 and equation 2. Now I use Roman numerals so we don't confuse our labels with the numbers in our equation. You can use regular numbers, but I do not suggest it because when you get equations like 2, 3, more than 2 equations, you want to keep everything as clear as possible. So we're going to use Roman numerals. So here you can see our second equation is in the form of y equals our expression. Now, it's easier for us to use substitution because we've already skipped the other question has already given us a few steps. So what we're going to do is because our y is equal to y in equation 1, we can substitute our y equals 3x minus 18 into equation 1. So I'm going to say substitute y equals 3x minus 18 into equation 1. Therefore, 4x plus 3. Now our y now became 3x minus 18 equals 37. Then I'm going to distribute. And if you need a refresher on distribution, I have a video of that. So we get, first we have 4x plus 3 times 3x gives us 9x. And then we have 3 times negative 18, which gives me negative 54, and that equals 37. Now we're going to collect our like terms. So 4x plus 9x gives me 13x. I'm going to leave my negative 54 there equals 37. And then we're going to plus 54 on both sides because we want to get rid of our 54. So make sure you have a plus 54 on each side of our equal sign. And that leaves me with 13x equals 91. Divide both sides by 13. And that leaves us with x equals 7. We're not done yet. And we need to substitute x equals 7 into, I'm going to substitute it into equation 2 because we already have it in terms of y equals. So we're going to say that y equals 3, our x is now 7, minus 18. And I'm looking at equation 2. And that leaves me with y equals 7 times 3 is 21. 21 minus 18 equals 3. And so your x equals 7 and your y equals 3. And that's how we solve by substitution. What if we have two equations like this? Now, I always suggest that you look for common factors in each of your equations and then simplify it. So if you can see in equation 1, they're all factors of 5. I'm going to say we're going to divide equation 1 by 5. And that gives me x plus y equals 5. I'm going to call that equation 3. Now we want to solve by substitution. So I'm going to have to make this in terms of x equals something or y equals something. I'm going to just make it in terms of x. I'm going to subtract y on both sides. And that results in x equals 5 minus y. I'm going to call that equation 4. Now I can substitute equation 4 into equation 2. Because we've been working with equation 1 this whole time. We've just manipulated equation 1. So we have to substitute it into the other equation, which is equation 2. So equation 2 is, now our x is now 5 minus y. So I'm going to change my x to 5 minus y plus 5y equals 29. Then I'm going to collect my like terms. So I'm left with 5. 5y minus y gives me 4y equals 29. I want to get rid of everything around my y, so I'm going to subtract 5 on both sides. And that leaves me with 4y equals 24. And we're going to divide both sides by 4, which leaves me with y equals 6. Substitute my y equals 6 into any of the equations. I'm going to choose equation 3. You can use any one of them, but that's looks like the easiest one that we're going to work with because the numbers are very small. So we have x plus y, which is now 6, equals 5, minus 6 on both sides. Get rid of our 6. And that leaves us with x equals -1. And that's how we solve our problem, which is y equals 6, x equals -1. Let's try another one. Again, we don't have our equations in the form of y equals something or x equals something. So I have to manipulate one of my equations to make it so. In this case, I'm going to use equation 2 because I have it in terms of a 1y here. So I'm going to say that from equation 2, just to show you my method, I'm going to minus 3x on each side. So minus 3x and minus 3x. And that results in y equals 24 minus 3x. I'm going to call that equation 3. Then I'm going to substitute equation 3 into the equation I did not use, which was into equation 1. And therefore, 4x minus 3, my y is now 24 minus 3x equals 19. Simplify. So I get 4x. Remember, we're going to use our distributive property. So we have 3 times 24, which gives me -72. And then I have -3 times -3x, which gives me a positive 9x. If you need a refresher, I have a quick review of negative numbers in another video. And that equals 19. Next, I'm going to collect my like terms. So 4x plus 9x gives me 13x minus 72 equals 19. I'm going to plus 72 on both sides of our equation. It's always on each side of an equal sign, so we keep the equation balanced. And we're left with 13x equals 91. I'm going to divide both sides by 13, which gives us x equals 7. Then we're going to substitute x equals 7 into, I'm going to use equation 3. It's because we have it already written in terms of y. So y equals 24 minus 3x is now 7. Okay, put it all in the same line, which gives us y equals 24. 7 times 3 is 21. So 24 minus 21 gives you 3. So our x equals 7 and our y equals 3. Let's try something a little bit more challenging. In this case, we don't have it in terms of just one x or one y, and there are no nice greatest common factors or anything like that. Now, for this problem, it's probably better to do elimination rather than substitution. But I'm going to show you how you do substitution for something like that. So, first thing we want to do is we want to make one of the equations in terms of x or y. I'm just going to do equation 2. So, from equation 2, I'm going to plus 2y on both sides of my equation. I'm just going to show you my work there. and that results in 3x equals 2y plus 6. Okay? I'm going to call that equation 3. Now I have a 3x here and I have a 4x here. Not easily substitutable. Now I can divide everything by 3 to make it equals x equals something and plug it back into equation 1. But I'm not going to deal with fractions. I don't want to deal with fractions if I can. So what I'm going to do is I'm going to find a common factor. And in this case, I'm going to multiply my equation 3 by 4. And that gives me 3 times 4 gives me 12x. And 2y times 4 gives me 8y. 6 times 4 gives me 24. Why did I do that? I'll show you in a little bit. I'm going to label this equation 4. Now I'm going to multiply equation 1 by 3. So I get 4 times 3 gives me 12x. Negative 3y times 3 gives me negative 9y. And 7 times 3 gives me 21. I'm going to call this equation 5. Now you see that I have 12x and 12x in equation 4 and 5. So I can substitute my 12x equals 8y plus 24 into this here. So I'm just going to show you that this section is now going to be plugged into my 12y. So substitute equation 4 into equation 5. And that gives me, now my 12x now became 8y plus 24. And then we're left with our 9y from before. So 9y equals 21. Put that all in the same column so you can see what I did. Now simplify. So we have 8y minus 9y gives me a negative y plus 24 equals 21. Try to find out y, so we're going to subtract 24 on both sides of our equation, always on each side of the equal sign. And that leaves me with negative y equals 21 minus 24 gives me negative 3. And we can change all the signs across, so y equals 3. I'm going to substitute y equals 3 into, which one shall we use? I am going to use number 3, equation 3, because we already have it in terms of x. So I can say that 3x equals 2. Now my y is now 3. I'm going to change it to 3 plus 6. Therefore, 3x equals 6 plus 6 gives me 12. And then we're going to divide both sides by 3. And that leaves me with x equals 4. Make sure you always box our final answer. So y equals 3, x equals 4. So that everyone can see your final answer in the mess of work here. Before I end this video, I wanted to make an end note. So you got a solution that where you found that, x equals x or 5 equals 5, that implies that there are infinite solutions, meaning the two lines lie exactly on itself. So it's touching itself infinite number of times. Conversely, if you got something like 0 equals 16 or 5 equals negative 2, a number that equals a number that's not itself, you have no solutions. No solutions means the lines are parallel and therefore never touch each other. I cover this more in my video on solving systems of linear equations by elimination, and I show you the graph depict these problems. If you like my video, please be sure to like and subscribe to my channel. I offer tutoring services online as well as notes, lessons, worksheets with full answer keys online as well. If you'd like to support my work, I also have a Patreon account. Links down below. Thank you for joining me, and I hope you found this lesson helpful.